All right, welcome back to Calc 1. We are looking at test 3 prep, and we are going to go ahead and take a look at this problem here. We have an oil refinery located on the north side of a straight river that is 2 kilometers wide. The pipeline is to be constructed from the refinery to a storage tank, which is located on the south bank of a river, 7 meters east, or 7 kilometers rather, east of the refinery. The cost of laying the pipe is $400,000 per kilometer over land, and then $800,000 per kilometer under the river to the tanks. Minimize the cost of the pipeline. That is all we are responsible for minimizing. We're not looking at environmental impact. We could take environmental engineering for that, but this is all we are concerning ourselves. We're just going to do one problem at a time here. And then when you guys do your environmental engineering or do civil engineering later, then you could worry about everything else. But we're just going to start putting pieces together one at a time here. So here we go. Let's draw a picture first. Okay, that'd be the first thing to do here. So we have our river. So put a little water in it so we know. Okay, we have a refinery. I'm just going to put it all the way over on the side here. Here's our refinery. And then here's the storage tanks. Okay, I guess I could put another little star here for storage. And we know that they are 7 kilometers away. So this distance here is 7, not drawn to scale, of course. And this distance up and down is 2. And then we'll deal with that. Okay, so the idea here is that we could go right across and then just draw this pipeline straight forward. Just going to go right across and do that. We could do the whole thing from the refinery to the storage tank completely under the water. Okay, that would be fine, or under the wetlands, whatever it's going to be here. Or we can go up to a certain point, a value here, and say that we'll call this part X, like some distance downstream from the storage tank, and then build it here and then go across. Okay, and that would be our two ideas of what we would do with this. So here we are with this part's going to be 7. I'm going to claim that this is 7 minus x, being that 7 minus x plus x, this would be the whole distance, would equal 7. That's kind of the whole point here. Okay, so we're going to go up to a point, then we're going to cross here up to this x point, and then we'll cross over. So what we're going to have here is we're going to have a 7 minus x. Let's go ahead and put that in here, times the cost of making a pipe on land. So 7 minus x. And I'm just going to go ahead and call that A, because I don't really like the big number. So we're just going to say A is equal to 400,000. 400. Yeah, I'm going to call it 4 for the most part of my my problem here. And then we have to go to get the amount under the water. Okay, and at that point, it looks like we have kind of a triangle here, right? We have a right triangle here. So we can use Pythagoras for this. And the reason I put my x all the way up here was so that I could do something clever like this and say we're going to have this distance. So we have to do Pythagorean. We're going to need x squared, right? That's this distance here is x. Okay, plus 2 squared, that's the distance over the river, times b. B is going to be 800. I guess if you really wanted to go with it, we could say that b is twice a, and then we could even be further along with what's going on here. But this is going to be my total cost of the river. Okay, so that's the cost of putting this pipeline down. Okay, so I'm going to go ahead and write this more of a calculus problem. So we're going to have 7 minus x times a. That's my eraser. Okay, 7 minus x all times a plus, and I'm going to go ahead and say this is x squared plus 4 raised to the 1/2 power times b is equal to my cost. Okay, at this point we need the cost over dx because we're taking a derivative, because we're going to try to minimize or maximize this. That's the name of the game here. So we're just going to minimize or maximize this. So we're just going to take the derivative of this piece here. We're just going to get negative a, right? We're taking the derivative of x. X times a is just going to be negative a here. Plus, and now we have to take this derivative. So we're going to get 1/2 x squared plus 4 to the negative 1/2 times the chain. So times 2x times b. We're setting this equal to 0 to see what happens here. Okay, so if x is equal to 0, the derivative still exists, so we don't really have to worry about this. Okay, so we're going to go ahead and say we have negative a. I'm going to go ahead and clean this up a little bit. 2's cancel. And we just have x over the square root of x squared plus 4, b equals 0. And now we have to go ahead and solve for x. So we're going to go ahead and sweep the other side to a. So we're going to have x over the square root of x squared plus 4 all times b is equal to a. I'm sorry, a, not x, a. So here it is with an a on the other side. All I did was just move this to the other side. We're going to go ahead and divide by b. Actually, no, we're not. We're going to go ahead and multiply both sides by, because the square root of x squared plus 4 is going to be a pain. So we're going to go ahead and deal with the fraction, and then we're going to have to cancel some stuff and move everything over. Okay, rather than introduce b being a fraction, like let's try to minimize what fractions we have to deal with. So we're going to have x times b is equal to a times the square root of x squared plus 4. Well, we have to get rid of the square root. So what we're going to do is we're going to square both sides. We don't have any pluses outside of the square root, so that's good. So what we're going to have here is we're going to have an x squared b squared is equal to, don't forget to square your a, and then times x squared plus 4. That gets rid of the square root. Now we can go on and do like just regular algebra here. So what we're going to do next is we're going to distribute. So we're going to have x squared b squared is equal to x squared a squared, just multiplying through, plus 4a squared. Okay, let's go ahead and subtract, because we're solving for x. So this is the goal, is we want to get x by itself. So we're going to have x squared b squared minus x squared a squared is equal to 4a squared. Let's get x by itself and factor the x out. So we're going to have x squared, and then we're going to have b squared minus a squared equals 4a squared. Now we're going to deal with a fraction. Okay, so we have x squared is equal to 4a squared divided by b squared minus a squared. It's a shame that does factor, but that's not really going to help us. But we're going to be able to say x is equal to the square root of this whole thing, 4a squared. We can simplify that, b squared minus a squared. Okay, so let's go ahead and simplify a little bit. So we're going to have x equals, let's say this is 2a, taking the square root of the top, and divided by, and unfortunately we can't do much with the bottom, we're just stuck with b squared minus a squared. Okay, here's where I'm glad I made simplifications to my numbers. By the way, get comfortable doing that, because simplifying your values in here with these costs and all of this stuff makes all of this arithmetic a lot easier. And it's just going to show at the end, it's like this turns into a much nicer, easier problem to deal with. So let's go ahead and unsubstitute. Okay, what was b again? B was, I think, 8 squared, and this is 4 squared for a. I'm going to double check by going up here. B was 8, a was 4. Okay, so we're going to go ahead and say that. So we'll go ahead and do that, and we're going to say x equals, this is 2 times 4 for a, and then we have the square root of 8 squared, which is 64 minus 16. Okay, and under a square root. I think we're going to be able to say something clever like, hey, look at that. So 64 minus 16. And I ended up with 48. So we're going to go ahead and save that for a moment. So I've got 2 times 4 is, okay, so I've got 2 times 4 over the square root of 48 under here. The square root of 48 is, I mean, 48 is really 16 times 3. So we're going to say this is 2 times 4. This is the square root of 16 times 3. Okay. So we're going to double check us on that. Okay, just making sure. Okay. So we're going to say this is going to be 2 times 4. So the square root of 16 is 4 times the square root of 3. These guys are going to cancel, and we end up with x equals 2 over the square root of 3. So that's the point at which you want to cross the water, cross the river from the storage tanks. So we're going to say this is going to be 2 divided by the square root of 3, and we'll say equals. I got 1.154. So this is 1.1545. 1.1, we'll say 155. Okay. So that's the point at which I want to go ahead and cross the river. Okay. So if I go all the way up here to my picture, x is going to be 1.155, 155. So 1.155 kilometers from the storage is where you want to cross, and that's going to lead us to our minimum cost. Now, it didn't ask you to do anything else, so that's okay. If you wanted to check out like what the whole problems are going to be, it may have asked you what the cost was. To minimize the cost of the pipeline, how far away do we have to do this? They didn't ask us for the actual cost, so we could go ahead and do this. Just remembering that x is equal to 1.155, we can go ahead and go back to our cost function, all the way back up here with our cost function, and say this is x squared, b squared. Okay, and then we had oh, never mind. We have x squared plus 2 squared over times b. Sorry, that's not what we want to do then. So we had 7 minus x. By the way, this is all we're doing for this problem. So if you're wanting to bow out now, that's probably a good thing. Okay, and then plus, and then what did we have for the other one? We're going to have x squared plus 2 squared. Okay, so this was the square root, x squared plus 2 squared, all times b, and that was going to be my cost. Okay, so we could do that. 7 minus 0.155, all times the 4 for a, plus, we'll say 1.155 squared plus 4. Take the whole thing under a square root times 8, and we can get our cost for that. Might as well go ahead and try that. I'm going to do it backwards. So I've got 1.155 squared plus 4 equals, and we're going to take a square root of this thing. Answer equals, so we're going to say this is 2.31 times my 8 plus 7 minus 1.155 times 4, and we'll go ahead and calculate that. Again, you don't have to have done this. We'll say this thing times 8 equals, and we'll go ahead and add this to 7 minus 1.1 0.55, okay, times 4. We get a total of 41.856. 41.856. Okay. What if we had immediately crossed? Okay, so we'd have 2 times B, because that's the amount of under the water, right? Because that's still rivers, plus 7 times A. If we had just done that, okay, that would have been A was 2 times 8, I believe, plus 7 times, how much was A again? Was 4. So this is going to be 16 plus 28. And I should be able to do this by hand, but we have 16 plus 28 is 44. So just doing a little test point to see, was this thing a minimum cost compared to like just crossing it and moving straight over to see what was going to happen? I guess we could figure out the whole river. So this is my 2 to 7. So I guess the whole distance is going to be the square root of 7 squared plus 2 squared. So that's going to be the square root of 49 plus 4, or the square root of 53 times 8. So if I go back to my calculator here, we've been the square root, we have 8 times the square root of 53. We get our answer, well, it was 58.28. So 58.28. So yes, our costs are lower than the 2 endpoints. Okay, so that's our minimum cost, or I should say, and the x value, of course, was 1.155. So this is X marks the spot. This is where you dig. Okay, thank you very much for watching. I went to New Mexico Tech, so this is one of the most important problems you could ever solve in Calculus 1. So I'm partial to this, but I will say that I also know that this is a hard problem to set up and to do, so I don't think I picked this one for your actual test. So thank you very much for coming along, and good luck with the pretest. Good luck with the test next week. Thank you.